everyone, p-brane here. I was actually putting together a much bigger video and I can't seem to get it done, but this pretty much says it. This is a short clip, but it's very powerful. This is to answer all those anti-flat earthers that come into the videos and they say, you know, if perspective is in fact the reason why the sun rises and sets, well then the sun should also shrink to a dot, you know, but we don't see that. The sun doesn't shrink to a dot, therefore it can't be perspective. Well, what I found is that most people are speaking from what we all know regular perspective is, and that's ground-based perspective, right? A car driving away from you, a train going away, maybe even an airplane going overhead that's not very high. What we learn in art class is that objects farther away on the ground level, they shrink, they get smaller, and that's how you learn perspective. What we've never learned is that in a flat Earth, perspective has everything to do with the celestial objects, right? So objects very high up behave differently than objects on the ground level. So, you know, a lot of people too, they say, how dare you? What are you introducing a new perspective? Who do you think you are? Well, okay, I am coming up with a new perspective, all right? And let's call it celestial perspective. What the heck? And basically say the law is this. Any object going away from you parallel to your eye line, which is also called your longitudinal axis or your z-axis, right? That's a line out from your eyes. And so in this case, we're going to speak in terms of ground level, which would be something parallel to the ground. So anything parallel to the ground, or your z-axis in this case, like the sun traversing over the flat earth would be parallel to the ground, right? Or the stars or an airplane or anything else. Okay, so anything traveling away from you parallel to the ground will follow this law. The higher it is, the less it will shrink. So the higher and higher it is, the less and less it will shrink relative to its starting size. I will show you with this little experiment and prove it, and that's it. Let's go. Okay, here's a little experiment I did. I have two 4-inch diameter wiffle balls, and I put them on the ground, and I have a tape measure and everything. So the two balls are 6 feet apart, and the camera is a foot behind the near ball. So that makes the far ball 7 feet from the camera, and this ball is a foot from the camera. Okay, now you can see the far ball is about 1/10 the diameter of the near ball, and this would be your z-axis. Anything going away on your eye line, a line out from your eye in any direction is your z-axis, and it will shrink a lot. But now, as I raise the camera up, you're going to see, look at that, voila. They're getting to be about the same size visually. I raised the camera up directly over the spot on the ground where I had the camera originally. And look at that. It's almost indistinguishable, just 7 feet up. So my law is, what I contend is that the higher the camera goes, or actually you can think of this as the balls going up. They're remaining parallel to the ground, but they're elevated. Kind of like the sun would do over the flat earth. It's moving parallel to the ground, but it's high up. So I've had so many people come to my videos, oh, the sun would shrink to a dot. And a lot of flat earthers say the sun does shrink. I'm not sure if it shrinks. I haven't seen any footage that shows that definitively. I have seen some that, you know, you could blame on blooming or flaring of the lens or whatever. And, you know, what I'm saying is this is a fact. The higher up the object is traveling parallel to the ground, the less it shrinks. Because it follows the very steep convergence angles down, which essentially makes the sun or anything moving away from you start to travel perpendicular to your eyes and not on your eye line. And that makes all the difference in the world, like I showed with the train going away, shrink, shrink, shrink. But when you raise the train up, now it's already shrunk the same size it is when it's far away from you. Okay, so here I have the balls next to each other, and you can see both balls have still traveled 6 feet away from the other ball. And you can see the higher up it gets, the less it shrinks. So there you go. Thank you very much.